Okay. Excuse me. All right, we are on 5, 6. Does that sound right? Hinge theorem, converse of Hinge theorem. This one's bigger, that one's bigger, right? What numbers did we do? 2 through 24 evens. Number 2, the measure of JL is less than the measure of KM. Number 4, the measure of angle XWZ is greater than the measure of angle YZW. Number 6, 7/2 is less than or equal to X is less than 24, so between 7/2 and 24. 8 is a proof. We can do it if and when we need to. 10, the measure of angle BAC is less than the measure of angle DGE. Number 12, measure of SR is greater than the measure of XY. Number 14, the measure of PS is less than the measure of SR. Number 16A is Joule, and all of the explanation for that. Whole bunch of stuff, subtracting from 180s and Hinge theorems, right? 16B is also Joule. Same sort of explanation. We can do more if we need to. Number 18 is negative 4.5, between negative 4.5 and 33. Number 20, X has got to be greater than 7. Number 22 is somewhere. There it is. Sean. Oh, that's my name. Haha, I win or something. And all the explanations for that, something along the lines of Hinge theorem, converse of Hinge theorem actually. 24 is a proof, and so is 26. So, what? We're on page 377. Right. What questions do we have? 20. Everybody online is whining about their Spotify Wrapped. They're like, oh my gosh, this says I'm 82. Oh my gosh, I wasn't listening to kids' songs, it was my children. It's quite funny. My Spotify Wrapped says I was 70, and I feel like I'm proud of that when it comes to music.
Mine was
67, nice. That's funny. Said my number one listened to song was Fishing in the Dark by the Nitty Gritty Dirt Band, and I can take that. My number one album was K-Pop Demon Hunters soundtrack, because it looks at bursts, and there was a chunk where I was listening to that a lot. And I can take that too, that's fine. I can deal with it, no problem. Number 20. Mine is also a little bit skewed because I use Spotify often when I DJ homeschool dances. So, I mean, I am sure that I have listened to Nitty Gritty Dirt Band on my own at some points this year, but I think that probably was my number one song, partially because I play it at dances. Because it's a good song. It's not the best two-stepping song, but it's such a good country song that it flies. We are expected to find the range of possible values for x. So, what should we do? I think we're missing some angles. There's really only one of which that we kind of need in order to solve this problem. What angle are we missing that we kind of need? Did you say that one? Yeah, it is that one. That's true. Which one? In order to use the hinge theorem, we need an angle opposite a side, right? That's kind of what we're going with. What? So the bottom left one. No, we can't say nothing about that. It's opposite, this is opposite the middle thing. We don't know nothing about that. Too bad. The which one? Top left. So this one is opposite this side, which we have something about. That's true enough. It's going to be harder to get to this one directly, although the fact that these are the same is helpful potentially. There is one angle we can get straight to that we don't know. Let's start with that. What is an angle that we can find doing one step? Excuse me.
Subtracting the 90 from 60.
Yes. We can find this one because this is 90. We know it because it's marked with the right angle, right? So this one, 90 minus 60 is what? 30. That's true. Okay, so we found that one because of that. Now that's not super useful. It's a little useful. It's across from this one, which is potentially helpful. Maybe. We can now find another angle. Which other angle can we find? How many degrees are in a triangle? 180, true enough. So using that information, is there another angle we can find? Which one? Which triangle do we know two angles of? Yeah, the top one. So we could find this angle by doing 180 minus 95 plus 60, right? So what does that give us? Positive. Better be positive, or else this triangle is impossible. Okay. So now what? What does the hinge theorem say?
The two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second triangle, and the third side of the first triangle is longer than the third of the second triangle.
True. So which angle is bigger? 60 is bigger than 25. That's true. So what does that tell us about this picture? Something's bigger than something else. What?
The top one, the bottom one is bigger than the top one.
The top what? Okay, so that might be true, but we can't say that. It's talking about sides, dude. Hey. Sometimes it feels like in this class that we don't watch the notes videos or like actually engage our brains with the homework at all. I don't quite understand in chapter 5 of geometry. I don't know what is going on because y'all aren't dumb. It's maybe partly because this is a small class. Sometimes small classes are difficult because nobody wants to talk because there's too much. What side is opposite of the 60 degrees? Let's start with that question. What side is opposite of the 60 degrees? The 25 is an angle, and it's on the other side, but which side is opposite of the 60 degrees?
5x plus 3.
The 5x plus 3. What side is opposite of the 25 degrees? What? Which 5x? The top one or the bottom one are you talking about? Okay, so it's not, but I'm glad you said the bottom one. So that's in a different triangle, right? It's this one, right? It's opening up to this one. The 25 is across from this guy, right? The 60 is across from that guy. This 5x is on the other side, but it's different triangle. Does that make sense? Okay. So 5x plus 3 is greater than 3x plus 17. I bet we can solve that inequality. What do y'all think? What should we do? Subtract, which one? Sure, that's fine. What's 17 minus 3? Team. Now what? Okay, so we wouldn't divide by 3, but that makes sense. We could divide by 3, but we'd have to divide everything by 3. We'd end up with all kinds of weird fractions. So you're trying to get rid of this one is what you're saying by divide by 3, which makes sense. But before we take care of that, we should probably get him with his buddy, right? So how do we get this guy over with his buddy? Subtract. What is 5x minus 3x? 2x. Now what? We can divide by what? By 2. That's true. Okay, so that's at least part of the answer, but we need to think about, is there another part of the answer? What are we trying to think about when we think about that? Do what? Okay, so x is the same. So we can't. We're finding the range. That's a good thought. That's not quite what we did in the video, right? I think. I don't know. Is this the video where I didn't do this part? Did I find where it's there's one video in this chunk where I didn't talk about something. But when we're talking about triangles, it can't be bigger than 180 degrees, right? Because then it's flipping around as a different triangle, right? So it can't get bigger than 180 degrees. It also can't be smaller than 0, right? That makes sense? Trust? Good. So, can we stretch smaller than 0? No. So it's got to be greater than 7, and it's got to be less than something else. But because this is locked in place, that's why this one is different. We should probably do one of the other ones just to make sure we got it. But because these are locked together, it can't physically get any smaller. So there's not a less than this number, like some of the other ones have. We should probably do some of those, just to do at least one of those, just to make sure we understand when there's a range of values. That's liable to show up on a test. It also, it's also because we're talking about a side and not an angle, right? That's another reason why, that's honestly probably the bigger reason why this is not a range of values. So is there any other ones y'all want to look at before I grab one of those that have a range of values? Let's look at like 17. I know we didn't get assigned 17, but let's look at 17. We may do 17 and 18. So, in your own words, what does the hinge theorem say? And you don't. I'm gonna keep that rhetorical, but I want you to use your. You don't have to. I'm not gonna necessarily wait for nobody to say anything, but I am going to explain something that if you will listen to what I'm about to say, your grades will go up in geometry. Period. Because it's what you have to do. It's like why we learn math in the first place. And so I'm gonna explain something. If you will stop when you are doing the notes, when you are doing the homework, when you are doing in class, and you will stop and you will ask yourself, why is this? You will do better. If you just copy, you will never make a good grade, ever. And maybe never good enough is maybe a better wording. You will turn your 72, you will, instead of making 95s, you will make 72s or 26s. You have to understand why a thing is. You have to understand, and whenever I'm giving a theorem, whenever I'm explaining a theorem, you need to stop and say, okay, in my own words, how would I explain this? That's the easiest way to do it. Okay? So the hinge theorem has all these words. You go and Mia chuckled when she read it out loud, and I understand why. Because you read all these words out from the page and from your notes or from the book, and it just sounds like a bunch of gibberish. Right? Two triangles, and this thing, and this included angle, and this blah, blah, blah. What the heck is even that? Right? Because it's all fancy schmancy words. You need to stop and say, okay, what does that mean? And if you can't do that, that's okay. That is 100% okay. You have to do something, you have to have another step. You have to either look up something else, you have to look up words, you have to ask me about it, put a star by the flipping thing and be like, okay, I know that this is the hinge theorem, I wrote it down, it's right here, but I can't figure out in my own words, what does this mean? Okay? Because then I can be like, okay, that's easy peasy, I got you. No big deal. Trust. Right? So I started this whole little schmagoigle with what is in your own words, what does the hinge theorem say? I said I'll keep it rhetorical because I'm not going to put anybody on the spot right now. So are you locked in, chat? Okay, this is what the hinge theorem says in plain English. Probably I kind of explained this in the video, but sometimes some of these things we need a little more, especially when we start saying included angle and all these other big words. Then it's like, okay, my guys are glazing over and I'm lost. If you have two sides of a triangle that are congruent, how do we know that there's two sides of these triangles that are congruent? Not the angles. Yeah, that's right. That's exactly right. And that's what I'm talking about with my own words. If you're like, okay, yeah, because that's great. That's what I want you to do. If you can describe things like that in geometry, you're going to be good to go. I love that. I want you to learn big grown-up words. That's great too, but like, I really want you to be able to be like, because of the that's great. I love it. It's good. We like this. Because of the tick marks, that's what those are called. We got two sides that are congruent. So the hinge theorem says if you got two sides of a triangle that are congruent, and you look at the angles that's inside of them. So this one's inside, that's a 57. That 5 looks a little janky, but that's a 57, I think, right? Yes, right. If you look at these angles in between them and they're different, then you can look at, okay, which one's bigger? And whichever one is bigger, they're opposite, the side opposite. And when I usually describe the side opposite as if you draw an angle. an arrow between it, but then we get on problems like the last one we looked at, and it's like, okay, well, I draw an arrow and it's pointing at the 5x. Right? So let me give you another way to think about the angle opposite. So yes, drawing an arrow, this one's easy, right? This one's talking about this one's talking about that one. That's no big deal. But if we were to shove these together, like I flipped this over and stuck it right here, then it's like, okay, well, what am I pointing at? I'm pointing at the 12 or something, right? But that's not even in the same triangle. So it's the one that if you were to start building the angle out from that thing, that's what it's going to intercept. Make sense? Are you locked in, chat? Because you kind of went to sleep for a second. Welcome back. What? Okay. So the side opposite is going to match. So if this one is bigger, then this one is bigger than this one, right? That's what it says. We have a symbol in math for bigger than. What is the symbol in math for bigger than? Yeah, that. Great. It's good, right? It's bigger than this. So 12 is bigger than 3x minus 6. Easy money. Good to go. Then we can solve that inequality. That's easy peasy. What do we do to solve that inequality, Gavin? Add 6. I agree. Look how smart you are. I just said earlier, y'all aren't dumb. Don't pretend like you're dumb. You can do this, but not if you give up before you start. And not if you don't ask questions about when you're confused. You're doing the notes video and you're like, I don't even know what this guy's saying. Or, more likely, you're just copying what old me said. And by old me, I mean past me. If you're just like copying it down and you're turning it in because I told you to and you're going to get a 0 or a 90 if you don't turn it in on time. You have to, turn the brain on while you're doing it. And then you got this. Now what, Mia? Divide by 3. Sounds great. What's 18 divided by 3, Joe? Punch it in. Good job. Now, I like, especially with inequalities, to flip it around with the x on the left side, right? But you got to remember that the inequality is going to flip. So x is less than 6, right? Now, this is what I'm talking about. These are not locked together, right? These are not locked in. So this has got to be bigger than 0. Right? It's got to be, so it's going to be less than 6, but it can't go down and be negative. So we need another little chunk. So we have to say 3x minus 6 has got to be greater than 0. And that's easy to solve, right? Add 6. And then we've got 3x is greater than 6. And then we've got to divide by 3. And we've got x has got to be greater than 2. So the only other thing is we need to, now if you didn't do this, I would either count off 1 or I wouldn't even count off. If you just circled those, moved on with your life, I might not even count off. But we really want to write this as a compound inequality, right? So we put x in the middle, right? It's got to be greater than 2 and less than 6. Right? What other questions do we have, kids? Well, if y'all don't have any more questions, then I'm going to let you go early so you can work on studying for your test on Tuesday. What? We can do 24, sure. Let's do it. Okay, let's prove measure of WS is greater than the measure of WQ. We are given that VR is congruent to RT, it's already labeled. Where's V? Oh, there it is. Yeah. And we are given that WV is congruent to WT. And the measure of angle SRV is greater than the measure of angle QRT. And R is the midpoint of SQ. So we need to figure out what we should do. We always want to start by looking at, is there anything in the given that it tells us that we can say something about because of? The midpoint. We can absolutely use something with midpoint. So the fact that R is the midpoint of SQ, what does that tell us? What are congruent? Which ones? QR and SR or RS. This on this problem, it's probably 6 to 1, half dozen the other. How you write it, but yes, that's true. What do we write for the justification for that? Definition of midpoint. That's true. So we said that this is congruent to this. It's true. Might be useful to kind of like dot in what we're looking to prove, that WS, where is WS? That's this one, is greater than this one. Okay. What else could we do? It does tell us something about an angle. We might kind of try to label that color. Kind of make up our own little notation. The SRV, so this one, it says that this angle is greater than probably this one, I bet. QRT, yeah, this one. So this one is greater than this one, right? We have that written down, but it might be kind of useful to add it to our picture so we can think about it. Okay, so do we have any triangles where we know two sides are congruent, right? Because that's where we're headed with Hinge theorem. Yes, which triangles? QRT and SRV. So those triangles. So the fact that this is bigger than this, what does it tell us about the sides? Tells us one side is bigger than the other, some other side. The bigger one is bigger, that's true. Which one is the bigger one? Which side? SV, yeah. If this angle is bigger than the side across from it's bigger than this one, right? And that's the Hinge theorem. So the measure of SV is greater than the measure of QT because of the Hinge theorem. Okay, so we've got something about this side and this side. These two. This is greater than this. This proof is maybe a bit tricky because we got to kind of go through a lot of different places. We know that these two sides are congruent, right? We know that these are a part of these bigger ones. So we could get a relationship that said this plus this equals this, right? And we could maybe relate some of the things that we already have greater than with substitution and all those things. So how can we say that the measure of WV plus the measure of VS equals the measure of WS? What is that called? No, not transitive. The best one, no. What is WV? What kind of shape is WV? Line segment. So segment addition. If we have this one plus this one, we get the big one. That's what that says, right? So we can do that on both of the sides. And we've got some relationship we might could do something with, right? The measure of QT plus the measure of TW equals the measure of QW. And then the other side, the measure of SV plus the measure of VW equals the measure of SW. We just said it's because of segment addition. True enough. So now see we've got some pieces. See this QT matches that QT, this SV matches that SV. Some of those things are kind of true, right? We've also got some other things up here that probably match. Let's see. WV. Right here we have it WV and WT. Those are matching. We wrote them backwards, but they're matching, right? Oh yeah, this just gave us this. That's right. So they kind of match, right? We can turn them into equals, right? We can take this and turn it into the measure of, we'll even write it VW so it matches this one, equals the measure of TW. What lets us turn congruent into equals? What'd you say? You're kind of close. If you wrote that, I might even count it. It's actually one step back from a postulate. It's a definition. Definition of congruent segments. Yep. Right? So now these match, so we could do something up here, right? What can we do up there? We can substitute it. That's true. So we can do either one. Substitute it in this one to be fine. The measure of QT plus the measure of VW, right? So we're turning that into that, so they match because of this, equals the measure of QW. Substitution. So if we could turn both of these into, if we could isolate the QT and the SV, we could substitute back up into this guy. And then we have the right shape, right? Then at least we have an inequality, right? So if if we have like x plus y equals z, and we want to solve for x, what would we do? Yeah. How would you move it? Subtract. So you'd subtract. So same thing here. So we could subtract off the VWs from both of these and put them on this side, and then we've got something that we can substitute in a minute. Right? So we'd end up with the measure of QT equals the measure of QW minus VW, the measure of VW, right? My goodness, I have a hard time writing those letters. Right? We just subtracted this over here, right? We can do the same thing with this one. The measure of SV equals the measure of SW minus the measure of VW. That is the subtraction property, right? So now we've got something that equals QT, so we can put that over here. We've got something that equals SV, so we can put that over there, right? Trust. So SV equals this one. So the measure of SW or WS, and put it back to the way we're trying to prove it. I should have looked closer to what I was doing before I wrote the orders. Same thing, is greater than the measure of, we just did this one. QT, yeah, okay. Measure of WQ minus the measure of VW. We've got VW on both sides, right? So if you had 3x minus 5 equals 7x plus 2, how would we get the x's together? Subtract. Yeah, and if one of them was this way, we would add, right? Which is what it is, right? So since it's negative, we're actually adding, right? Oh, we didn't write what this was. This was substitution, right? Substitution. So if we add VW to both sides, what's going to happen to VW? What is negative VW plus negative VW? Excuse me. Plus, no, lies. It is positive 2 VW, but I said it wrong. So what is negative x plus x? Because that's what we're doing. No. What is negative 2 plus positive 2? 0. So these are going to cancel, right? Measure of WS is greater than the measure of WQ, which is what we were after from the beginning. I think we went a slightly different direction than the book did. I think we had all the steps. I think we just did them in a different order. There's a lot of shenanigans in this proof. It's a convoluted one. But it's all kind of one step after the other, using stuff we've already done. Now I'm going to let you go. But not really early this time, just like 2 minutes.